Welcome, everybody, to ITU and to our first lectures. So I'm extremely proud that we are here today to celebrate our first professors. And so we have designed this as a series where we always will present two of our professors at a time. And of course, we cluster them according to topics. And in this case, it's according to the last name, you know? So it's Frauenberger and Wintersberger. No, it's actually clustered according to human factors. Human factors will be one of our major research areas, focus points, which ITU will engage in. And human factors is essential for the adoption of digital technology as a whole. It has been over a long time. So if we just remember the DOS operating system with this command line, yeah, so this was not really very sexy. And then Windows came and mouse, and that was already enticing a few more people to actually use computers. And then the smartphone kind of swept all over us. And the smartphone is really an incredible design artifact, which Apple there produced. And so from there, we go on to augmented reality and other technologies which we want to bring into society, into the use for humans and the interest of humans. And well, in the history, the US has been very, very strong, the IT companies in this field. And I think it's time that we in Europe join forces. Of course, this is not something we only do ourselves. Professor Ferscher from JKU has a long history on human factors research. So it's about building a hub, coming together, a network in driving this kind of research forward. And in doing so, I'm very, very proud today to present to you our first rock stars of human-computer interaction, human factors, and who will establish this kind of network and drive it forward. And just to begin with, I want to give you a little bit an introduction to each one of them so that you have a little bit an idea about their CV, what they've achieved so far. So let's start out with Christopher Frauenberger. So he has a very strong basic background in computer science. So he studied telematics at Technical University in Graz and then went on to Queen's Mary to do his PhD. They already was very interdisciplinary in the sense that he looked into auditory displays for the visually impaired. So not just visual, audio, bringing this all together. And then in a postdoc at the University of Sussex part, he looked into how we can develop learning technology for autistic children, which is increasingly becoming a very strong topic all over the world. He then went on to become a professor at Plus in Salzburg, the university there, leading a group on HCI. And well, now he is one of our founding professors, the founding professor of human-computer interaction at ITU. His background being in CS, he has slowly, increasingly draws from methodologies and theories from other disciplines such as social sciences, design, art and design, and increasingly philosophy of technology. So this is our first one. The second one, Philipp Wintersberger. also has a very strong background in computer science. Not all our professors will have this. So this is why I'm just specifically pointing this out here. And he has been investigating the potential of AI for novel interactions, human AI interactions, in order to really have this kind of personalized interaction in the future. He started out here at this location with the JKU, did his master's in computer science, and then went on to Hochschule in Ingolstadt to do his PhD in a topic which still is with him. It's on driver vehicle interaction in automated driving. And this one topic, which is kind of with him for a while, is to looking into how attention is between different things what people are doing. How can we steer attention from one point to another in order to enable people to really work in also safety critical environments. His postdoc then led him to AI for working environments and safety critical systems. And and then he went to his first professorship at the FH Hagenberg, from which he then joined ITU as the professor for intelligent user interfaces. And also with him, he is increasingly drawing from other disciplines, specifically psychology, design, and understanding and designing tools for managing attention. So, and with this, I already want to hand over to our two rock stars. And so let's rock the house.
Thank you. Thank you. Thank you. We're tremendously honored and proud to kind of kickstart this series of inaugural lectures at this new university. And in true fashion and spirit of the ITU, we will do this in an interdisciplinary and collaborative way. So what you're going to go and experience today is not the usual kind of 30-minute talk that every one of us gives, but we do a little bit of a double act. So we hope we can interweave our topics and talk about a few things that our research brought up.
Yeah, thank you everybody for coming. The topic of our talk is human-centered computers, a non-trivial problem. And we will give you some broad overview of what we think about computing in this space, and we'll also do a deep dive into some of the projects we are working on.
So, humanity has always been very intrinsically linked to the kind of technologies that it gave itself, right? The fire, the wheel, the printing press are very popular examples of this, how the trajectory of human condition on this earth kind of really changed. Some of these technologies are very prominent and open, and everybody knows about them, like those. Some of them are more mundane and inconspicuous in a way that they have, in very consequential ways, steered how society has developed. And one of the historical examples of this is the stirrup. While its invention, of course, was much older, its application in the military context in the early Middle Ages really changed everything back in that day, because it made the cavalry a military force that is decisive. And it also, and more importantly, required villages to kind of collaborate and structure their collaboration totally new, because they needed to kind of provide riders for the king. And in that way, Lynn White argues that it has actually laid the foundation for the feudal system that then has structured the society for many centuries to come. So some technologies also kind of looked like a good idea at the time, but then maybe turned out to be consequential, but in a far less desirable way.
Yes, so this is an AI-generated image of what happened in the early years of the last century when radioactive materials were discovered. And often with new technology, we as humans are very enthusiastic about it, and we want to use it for all kinds of purposes. And so we had the situation that there was radioactive jewelry, for example, and we're also cutlery. And these kind of things are not really healthy, we have to admit, but these people didn't know back then. So sometimes it also takes quite some time to realize that some of the inventions that we make are not always, really the best thing of what we could do. The story goes on, for example, in the 1950s with nuclear technology, where some researchers proposed that many household appliances could have their own nuclear reactor inside, and so to say, would never need to be plugged in and the battery would never run out. So these technologies never made it into reality. But we also have situations where we were so enthusiastic about things, about new inventions, that it took us nearly a century to realize that maybe we did something wrong in how we as a society were too strongly driven by the ideas. The one example is cars. So cars are a cool thing. They make you able to transportation very fast between two places. But actually, it turns out that we have built entire cities and spaces, mostly focusing on what's good for the car and less what's good for the people. And don't get me wrong, I am a car enthusiast. I love driving, but I don't consider these kinds of situations as a very funny activity. But these days we start discussing about maybe we have made something wrong. Maybe we should transform our environment again to become more friendly to the user. So this is a recent video presented by Toyota at CES. It's called the Woven City. So in that city, everything is connected through digital technology. As an utopia, it allows us to reconfigure urban societies in a more just and sustainable ways. But it could also be seen as a dystopia that turns our environment into an Orwellian surveillance state. So these digital technologies challenge core human concepts like autonomy, responsibility, and agency. And when you walk around San Francisco or drive around San Francisco these days, sometimes you don't even know if you would interact with another driver or with an automated system controlling a car. So it's increasingly unclear who we are interacting with.
So this is now a chance for participation. Who of you has spoken to their phone today? Okay, well, that's our fourth, I guess. Who has ever spoken to their phone in a way that is, considered more an elaborate conversation, maybe? So not just asking or commanding. A few, right? Who feels an emotional connection to their mobile phone? Now think about when it runs out of battery. Yeah. So when I do this with the school class of my son, who's 14, the numbers go up, right? This is quite clear. But it's quite strange, isn't it? It's like something has changed. Our relationship to digital technology has changed. Digital technology has reached interactive capacities that evoke quite strong emotional responses. Did you feel sorry for that robot? When this video is being shown to people on the street, they react like this. Oh no, poor robot. And that's strange, isn't it? Because we wouldn't react that way if somebody would have kicked a lamppost or a car. Maybe some, but not us. But why do we have these emotional responses? And does that not also kind of make us vulnerable for emotional manipulation through technology? Digital technology also kind of challenges in many other ways. It's like, what is true and what can we trust? The days in which we as a public can have a debate or a discourse in a common frame of truth or a shared ground of reality, these days are over, right? We need to kind of find new ways to kind of make sure that our discourses are not disintegrated and that we actually can talk about the same thing, right? So all of these, of course, are not true, right? They're generated. So technology can be a very powerful agent in undermining this shared common ground. And we see it weaponized by economic and political agendas every day. Right? So a recent example might be that Meta has decided to kind of not fact check their content anymore. Whether that is entirely true or not is debatable, but it's a powerful sign, right? This is a picture of Donald Trump's inauguration just on Monday. And I've put it in here because I found it really extraordinary that the first row is full of family and close allies of Donald Trump. And in the second row, you have these four people: Mark Zuckerberg of Meta, Jeff Bezos of Amazon, Sundar Pichai, the founder of Google, and of course, Elon Musk. So big tech is doing big politics. And that, I think, we should be worried about. But the point here is not that we want to be pessimistic or even kind of anti-technology. I think Melvin Kranzberg says it really well in his 6th law of technology. Technology is neither good nor bad, but it very certainly is not neutral. So whatever we do with technology shapes our societies and reconfigures power. And we as designers and creators of that technology, we need to be aware of that. So that leads us to the framing of the talk today, the core central questions in a way. So that if the technologies we build and shape, if the technologies we build shape who we are, how can we then design them to help us to become the people we aspire to be? Can we provide alternatives addressing the problems these technologies have already created for us? And can we design meaningful future relationships between humans and highly autonomous systems? And I believe, Philipp, you have done some work on configuring meaningful relationships around attention management.
So sorry. I was just in the middle of something. Important messages coming over all the time. So we recently, there was a slide on a couple of populists. So let's do some populist raise your hand questions too. Who of you thinks that the protection and safety of children is one of the most important things for our society? Please raise your hand. Okay. Now raise your hand. Who of you has used a smartphone in a car? These things don't go well together. But we can also go to less critical examples. We live in the age of disruption. Maybe you have been in a situation where at a family dinner, somebody reminded you to please put away your phone at this important moment. Or you were working in the office on something really important. You need to send it out today. But over the course of the day, many times there were messages incoming, and you didn't continue working. You just reacted to all of them and replied to all your contacts, looked at all these cat memes and so on. So there is research out there that tells us that this permanently switching between different activities has led to high socioeconomic costs. This can be the productivity loss at the workplace, but it could also be injuries or fatalities in a safety critical environment like driving. So with this first part of this talk, I want to guide you through some of the research that we did in our FWF project, AI Attentive, where we tried to use AI technologies to better deal with the limited resource of human attention. Because one thing is clear, the computing power permanently increases. It had increased for the last years, and it will continue increasing. But our attention space and our limits, we're not keeping up with it. We are limited by our biological systems. So we did a couple of studies to find out, okay, how can we improve the situation? That's a very recent example of a study we did. So we were putting cameras in people's heads, and we recorded their behavior over 1 hour of focused work. This is actually a fast forward of my recording, so there is no privacy, except for Chris, you appear in the video at some point. Never mind. So afterwards, we asked people to annotate the videos and tell us when and why they switched to a different task to find out more about their working patterns. So what could we see? We could see, I mean, what would be very good is like to get in this flow state of high productivity and focused attention. It would take you about 10 minutes to 20 minutes to get into that state, but typically it doesn't happen. So in our experiment, people were working on their core activity mostly, average no longer than less than 3 minutes. And it only occupied 62% of their time. They also switched between different tasks about 30 to 40 times on average within that hour. I mean, the good thing is often they also switch to other activities that are somehow related to the primary task. For example, getting information from the web or calling a colleague or so. But still, a significant proportion of the time, 22%, was dedicated to off-task activities, meaning responding to messages, checking the phone, being entertained, finding out more of the cat memes yourself, and sending them to your colleagues, for example. So often participants in this study say, I'm not really affected by that because I have always put my phone in silent mode. But however, this does not always really prevent you from this kind of distraction. So interestingly, people frequently then check their phone by their own intention to find out if somebody has sent them something important. And also it's not always really useful because we have many devices these days, laptops, phones, smartwatches, and notifications are coming from all of them. So just putting your phone in silent mode doesn't really solve the full situation. But we also looked at these kind of situations in other environments. So for example, in driving, so we looked at what is the effect of smartphone use during these so-called takeovers, where a semi-automated car would prompt you to take back control of the vehicle to react to a potentially dangerous situation. Here, participants would have to realize quickly which of the 2 lanes they should go into and then make an informed decision and not crash into this balloon obstacle. Or we also looked at bicycles. So these days, also on bicycles, use their smartphones from time to time. So in the study, we sent our participants messages and told them, please only respond when you think it is safe. And we look at their gaze patterns during their activities, and we could see, okay, while and for some of the participants, this was also a new thing. So in these first messages they got, they were still monitoring the environment for quite a lot. But later on, when they felt, okay, it works out, they were only looking at the smartphone. So typically at the end of these kind of talks, I get the question, isn't it dangerous to do this on the road? So I will quickly show you that we used a so-called modified parent-child tandem for that, where an experimenter was sitting at the back and have full control of this bicycle to prevent any safety critical situations. So in these kinds of studies, we could find out that multitasking with nomadic devices is prevalent in many real-world situations, and user behavior is influenced by a wide range of factors here. We also could see that the negative effects of these switches, so whenever you switch between activities, it takes you some time to reorient your focus to the other activity and then coming back. This accumulates over time, and this is, so to say, the cost of multitasking. And this cost can be mitigated by a so-called attention management system. So what is an attention management system? It computationally seeks to balance a user's need for minimal disruption and the application's need to deliver information. Or in other words, we should only interrupt and notify users always, but only when necessary or when acceptable given the currently ongoing task. So as a next step, we wanted to find out, okay, where could users even imagine to use these kind of systems? So we performed a vignette study. Vignette studies mean that you would immerse participants in a particular situation by telling them a story about it, illustrated with a picture or a short video, and then ask them questions. So we asked them for multiple situations. So imagine you would be an air traffic controller, or you would be a programmer, or you would be in the living room watching a movie with colleagues, and suddenly a message comes in that could either be from a working contact or a private contact, could be a highly urgent message or just a casual thing. How long can this message be delayed to not disturb you in your activity? And we could see that there would be high acceptance, especially for this work and safety critical settings, and users actually would permit delaying notification, in particular for non-critical messages from both private and professional contacts. Also, to make an AI system perform decisions about these notifications, users would grant access from various data sources like operation system data, which app is open, where is your mouse, and so on, but also physiological measurements like eye tracking or their fitness devices. What they did not like, for example, is if someone would make a video of their activities to make these kind of decisions. So we thought, okay, then let's build such a system. I mean, actually, the idea of attention management is not that new. It was even articulated 30, 40 years ago, because people back then already knew that at some point we will need these kind of things to deal with all the overwhelming information flow. So the problem with existing attention management concepts is they don't really work in real life settings. For example, they need complex machine learning pipelines to detect user states, to detect breakpoints in activities, or to perform decisions. But activities are complex, and human behavior is also very complex. Also, it would require experts who label the training data for these systems. So some experts, like you, would have to sit somewhere and clearly define what would be a good breakpoint or not a good situation for an interruptions. And this makes another downside. They can only become as good as the theory or expert knowledge would suggest. So actually, it's quite unclear how to design an algorithm that would integrally cooperate with the users to make them better multitaskers. And I told my team members that if we can somehow contribute to this problem, I'm pretty sure we will get some awards. So we tried to find out another approach. So actually, after many different experiments, we use reinforcement learning, another branch of AI technology, which tries to optimize its behavior towards a reward function by exploring and trying out things in an environment. So this means a reinforcement learning-based attention management system would be less task dependent. It would not need labeled training data. By that, it can also adapt to your personal behavior, and it could achieve superhuman performance, because maybe there exist strategies for task switching that are not really covered by the theory. Often, AI can discover novel things. So we postulated the hypothesis saying that we can design a reinforcement learning-based attention management system that would improve human performance. Actually, car driving, office work, that's very complex. So we really had to go down for our first trials. This is the setting that we came up, the dual task situation, where a user would have to balance two balls on two dedicated platforms, but they could only control one of these platforms at any given time. And they would have to switch between the platforms with that gamepad and control the platforms with a joystick. So the task was to never let one of these balls fall over the platform. And as like with a Tetris game, these balls would become faster and the platforms become more slippery. So at some point, anyone will get game over. So in other words, the longer you can play this game, the better. And we said, okay, can we train an attention management system that would make these task switching decisions, so attending the left or the right platform, better than the users themselves, if they would themselves make these decisions using the gamepad. This is a short video of our trained system where Alex is only using the joystick, no need for him to switch between the platforms, and the AI system in the back will always decide which of these platforms needs the attention the most, so that he would not get game over. And after long training phases, we made an experiment with more than 40 participants where we could show that our attention management system could significantly improve human performance in the game, and the participants performed up to 1 × 5 better than in other modes like self-playing mode. We could also see that the behavior of the attention management systems changed people's playing style. So for example, when they were playing themselves, they spent more time on the platform and also waited for more relaxed situations before switching to the other platform. The attention management system, however, made them switch more often and in more difficult situations. Okay, maybe they could play the game a bit longer in that case, but this also sounds very cognitively demanding. But at least when we look at subjective perception, it was not. So playing with the attention management system was still perceived as less cognitively and physically demanding than in self mode. So with that, we had shown that attention management with reinforcement learning can significantly improve users' performance, and that our attention management system could derive multitasking strategies that counter theory by provoking fast-paced playing without negatively infecting workload. So we think intelligent user interfaces that learn from and adapt to the user could be utilized for a wide range of cooperative tasks like distributing activities between humans and machines, effective teamwork, communication. Yeah, I think this was really a great experiment, and as promised, the team also got the award later for that. So.
Philipp, your work here focuses on attention in a very performative kind of aspect, but of course, human attention is also something that is contributing to other human behaviors and general well-being, right?
Yeah, that is true. I mean, well-being will be one of the core foci for our project in the next time. But its attention is intrinsically linked to well-being at all. But nevertheless, I mean, Chris, I know you do a lot of work in more vulnerable settings. For example, care for the elderly. Maybe you can talk a little bit about this.
Thank you. Well studied. Glad you asked. I wanna take you into a project of mine that's called Caring Robots, or Robotic Care. This is a project that was funded by the FWF under the Connecting Minds funding stream that aims to bring together researchers and non-governmental organizations for joint research projects. And we collaborate together with colleagues from the Technical University in Vienna, and care experts from Caritas and the Technical Museum in Vienna. And the overall question is, like, how do we think about robots in care? And I mean care for the elderly. So if you look at the kind of public narratives that are out there, people have quite strong opinions and quite strong pictures in their head about what robots in care might look like and how such a future might be desirable or less desirable. And these kind of visions or these kind of pictures that we all have in our head, they clash with reality, not only because robots can't do any of the things that you have in your head at the moment. While the progresses in robotics are, of course, astounding, just picking something up from the floor is quite a lot of effort and a very complex problem, and also very cost intensive. And this is one of the kind of drivers that people that people use to kind of think about robotics in care is cost efficiency, because we see that we will need more care for the elderly in the future, but we have less and less care workers. And of course, there's other motivations also behind that, but that is one of the drivers that stand behind that. And we can debate whether that's a good thing or not. But the other thing is also that these images don't reflect the reality of care either. They look like the happy kind of elderly person kind of shaking hands with a robot. This is not how care looks like. In Vienna, there are no planned admissions to care homes anymore. There are only emergency admissions when it really becomes impossible for any person to kind of live individually in their home. 80% of the people in care homes in Vienna have a diagnosis of dementia. And the average time that people live and stay at care homes is now around a year. So the reality of care looks quite different to what we have in our head, of course. So the result is that in research and innovation, the directions are slightly different and divergent from these kind of public narratives. They go more towards these slightly more mundane applications like lifting devices that for some reason have a bare head. I don't know why, but or other robots that implement stuff like physical exercise or cognitive exercises for the elderly. A classical approach by technologists to this area is like they go in and think about what is the main challenge in care work, and then think about what can robotic technology do to solve that challenge. And this purely functional approach leads to a great problem that many of these technologies that come out of there are not accepted in that context. So what we try and do with this project is to think from the other end. So we start with a very different question. We don't think about the main challenges in care, but we think about, hey, what is good care to begin with? And then we look at care as a socio-material and socio-technical system. That means that a lot of very different stakeholders and materials contribute to a network of care or a system of care that either produces good care or not so good care. So we have care recipients, we have carers, but we also have institutions with policies, we have relatives, we have all these kind of stakeholders negotiating something like autonomy of the elderly versus a duty and a responsibility for their well-being, and so forth. And the question now becomes like, what kind of roles of robotic technology can we want to envision in that very complex system to go forward? And how will that ultimately also change the way we think about care? So that is not a stable condition either. So in our project for the first 2 years, we kind of really spent a lot of time in care homes in Vienna with a lot of time from our team to do observations, to understand the way how care is performed, how care ticks, and what makes good care. So we did observations, interviews, we did card-based workshops, we did some speculative vignettes, which is also a very common technique in human-computer interaction, that you first start and speculate about possible futures and then go back into the field and see how that resonates with the stakeholders in that particular setting. And what we found was that very common and important themes of good care are first of all putting relationships centrally. So good care is relational and is trustful, and it needs time and routines to become trustful and good care. It is a constant negotiation between all these stakeholders about, starting with the very mundane small actions that a caregiver would do on a care recipient, to all the way up to kind of institutional policies. It's all a negotiation between conflicting tensions and agendas. Care is very emotional, on both negatively and positively. So positively in the way that a lot of people report that they really get a lot of job satisfaction from being able to care for somebody. And that's an important point. And it's reciprocity that really matters. So it's a care that you give and receive in equal measures. Self-care is something that we found really, really important. A lot of the problems that we see in care work, that we don't get enough care workers, is attached to the very specific demands of that job. And of course, we also kind of had a very keen eye on what is the role of the people, but also what is the role of the materials in that setting. And so we started to kind of write vignettes, and we started to write robots into these vignettes, right? So what could be the role of robots in these vignettes? And we have one, and I'm not going to read this out for the purpose of time, but we've got one vignette here that kind of deals with self-care, another vignette that has this triangle of interaction between a care recipient, a caregiver, and a robot. And it's a bit of like a good cop, bad cop situation where the caregiver is the good cop and the robot is the one that very strictly kind of follows all the rules. And just by kind of giving these entities in that care situation different roles, we can create a very different dynamic. We then did a very elaborate kind of series of participatory design workshops where we kind of went into care homes, involved caregivers and also care recipients in a series of workshops around robots, about computer vision. We played around with conversational AI, and we tried to kind of get stories and situations in which robots might provide a meaningful addition to that care network. We also kind of did something specific around documentation. We played around with LLMs that helped document the documentation process, because we saw that as a main pain point for a lot of caregivers, that documentation was taking up a lot of time for them. What you see here is this is a training environment where caregivers kind of train all these kind of care activities, and you would have a companion that comes with you and records what you do and then provides you with some text that you can work on and put into the documentation system. And with all these kind of inputs from the field, we went into a series of hackathons, because we felt the need that we have learned so much about this very complex system. We needed to kind of translate that into actual and very concrete concepts of robotic technology that we wanted to introduce in this concept. So we did this with the research group. We brought together additional kind of caregivers from our partners, roboticists, technologists, researchers, and into the technical museum in a very nice room. And we tried to kind of come up with different stories that would exemplify the roles of robots in good care. And we also did a second series with a class of human-computer interaction students, master's students, who had very little knowledge about the actual context, but we provided some information for that, of course. But they had a lot of expertise in design. So we kind of had a very broad and versatile bunch of ideas that we are going to implement. So this is roughly where the project is at the moment. Our current stages is that we're starting to implement these concrete concepts on actual robotic platforms to kind of go back into the field and then try them out and see how that changes the dynamics of care. And this is one of the actual concepts that we envisioned there. It's a semi-automatic system that kind of drives around a care home and picks people up that seem to be a bit lost, and provides them with information from their biography. So they're connected to the biography work, and tries to kind of engage them in an interaction and a conversation, and by that also kind of collects data about their well-being. So when you can tell quite well from an interaction or a conversation about their dementia, for example, whether they're having a good day or not. And what is really complicated here is to get the point right that you're not pretending to care through the robot, but to kind of get the handover between the machine and the human carer right. So you want to actually understand the needs of somebody through that system and call a human carer whenever that's appropriate and necessary. And that's a really difficult problem. And it really is something that kind of is aimed to kind of strengthen the personhood and autonomy of people with dementia in that case, and really pays into this well-being and feeling safe. But of course, that requires a very autonomous system be trained in a way so that it can be very personalized. And it really matters that these interactions are not generic, they're not scripted, but they're actually tailored towards the people who, by accident, stumble into this robot and are being led around.
Yeah, this raises some questions, Chris. So, I mean, these robots will somehow need to adapt to all these different people who have different personalities and characteristics. How can you guarantee that it would really satisfy the needs of each individual?
Yeah, and that's a huge problem. And some of that information obviously comes from the biography work, but that's only also as good as the relatives, for example, feed the system. So training such systems to the needs of very different people is a problem that I think you have worked on, right?
Let's have a look. So in the second part of the second part of my part, so now I'm getting confused. I talk about human modeling and simulation. So I come back to this ball balancing game that I've shown you before. So maybe some of you have asked yourselves already, how is it possible to train this kind of AI system? Because it would need many, maybe millions of steps for training. And also the AI system works very weak at the beginning, and it's not very fun to play with it. So training with real humans is somehow infeasible. I cannot all put you in a room for weeks to collect these millions of steps, and then maybe later on I realize, we made a mistake in our code, or we have to change some parameters, so please take another vacation again to support us. So actually, we have to come up with another solution. And when people who work with AI don't know more what to do, of course, our solution is to come up with another AI system that could do this task. So we need simulated humans that achieve realistic results that would behave like real human users that we can use to train our system. And this also poses another question: how can we assess whether the simulations that we build are really realistic? So when I talk about an AI system playing this ball balancing game, you can imagine they are too good. They are not comparable to humans. I'm not saying that AI would be in general as good as humans in any task. It's by far not the case. But in the skill-based activities, like this balancing, you would never see a reaction time of a robot. They would just play perfectly. So think about it. Are we as humans seeing reality as it really is? No, actually not. We have all these inputs from our senses that are then constructed in our brain to our perception of reality. And this is roughly an analogy of how we extended these reinforcement learning agents to replicate human behavior. So the concept that we were applying here is called computational rationality, and we were lucky to cooperate with researchers from Aalto University who brought these topics into our problem and said, maybe this is something that could help you here. So computational rationality has the assumption that we as humans would perform optimal under given bounds. So we would do this task of balancing as good as we can do it, but we're limited by our constraints, where we focus our attention to, how fast we can control a joystick, and so on and so on. So the combination of reinforcement learning with computational rationality can simulate humans when we appropriately model these constraints into the systems. So this means that in our implementation, the agents would not operate on the true environment. They would never know where the ball is really on this platform, but they would see an internal environment that is represented by this constraint action space. So we did this by modeling a so-called belief state that was implemented as a partially observable Markov decision process. So here you can see in a very simplified 2D version how our agent will see the reality when they are distracted. So these red bars represent the probability distribution of where our agent believed the ball would most likely be. And you could see that the black ball is not exactly at that position where the probability is highest. So this allows us to model a situation where our simulated user is not really attending the task because maybe he's playing on the other platform. But when he then switches and gets this platform into focus, we can change this distribution, and suddenly we have the spike here, and the agent will suddenly have an exact sync of the probability and the real ball position. So you can see that in this video here. You have this patent ball that represents the real position of the ball on the platform, and you have this white ball always lagging a little bit behind, where our simulated user believes that the ball really is. Also, the green platform is the platform where the agent is playing, and here these balls are quite close in sync, while on the blue platform, over time, the deviation between the real position and the believed position increases. So by that, we can model a more realistic behavior, and we can also change these probability distributions in a way that we could record, for example, your playing style, and then parameterize the agent to have a similar behavior as you would have it. This is actually the only way how we manage to train our system in a way that was really beneficial for users. And currently, we're extending these kind of concepts for other domains. So this is a representation of recent work where we came back to this original model of driving a car while putting some characters, let's say, in an infotainment system for navigation or selecting a contact. And you can see also that our agent is either looking at the street or on the display, and whether it's, for example, looking at the keyboard here, the chances that they will hit the right button are different in a comparison when the agent would not look at the keyboard at that particular moment in time. So our next steps will be to reevaluate our attention management system in these kind of more real-life settings to really show a beneficial effect in potentially realistic applications. So in many skill-based activities, we can simulate human behavior realistically using this combination of reinforcement learning with computational rationalities. And we can then use these models to train intelligent user interfaces that adapt to the user. However, we have another question. How can we assess if these models that we build would really behave realistically? And here it starts where, being a team member in our lab gets really exciting. So we use VR simulators to assess people's behavior and compare their behavior in the simulator with these kind of simulations that we build. So one thing that we want to set up here at ITU is this multi-user traffic environment where a user on a bicycle could meet another study participants driving in a car, for example, to research this kind of encounters. Personally, I have worked with these bicycle simulators also in the past. I think they are somehow a little bit of a gold standard of VR simulations. Why? Because on a bicycle, your personal mass represents up to 90% of the overall system. So even small changes in your behavior drastically affect these, the entire combination of human and the bicycle. So at TU Wien, we built one of just a handful of motion-based bicycle simulators in Europe. And we thought, okay, to make this cycling more realistic in VR, also the bike needs to tilt somehow. But of course, we don't have centrifugal forces here in the simulator. So if we really tilt it as in real life, people would just fall over to the side. It doesn't work. So we need to find out a better function that would just do a slight tilt, but still give the user having the VR goggles on the impression they would be on a real bicycle. And we experimented with many different functions to achieve that. And one result that we had is we found quite a good sweet spot that could increase the immersion of our study participants without creating additional motion sickness. And you can assume motion sickness is really a big problem in these kinds of simulations. But I also have to admit, this simulator is far from perfect. So we have to do many more iterations. We already have quite some new design ideas in our heads and how we could improve the situation even further. So we can use these simulators, as said, first of all, to make measurements of human users and see would our simulations roughly correspond to their behavior. But at the same time, we can also use these simulators to ideate novel interaction concepts that we could test out that could, for example, help in mobility settings. This is something that we did in our FFG project, The Future of Cycling, called Eternity Bike, where we investigated different advanced driver assistance systems for bicycles. So in particular, we used all the soft and hardware to implement two very common systems in car driving, namely adaptive cruise control and lane keeping, and evaluated them with a wide range of participants. Thereby, we could, for example, show that adaptive cruise control, or in German, ein Abstandstempomat, would be well accepted by potential users, and it also increased the cycling performance according to some of the performance measurements that we employed. In contrast, lane keeping systems, they were not really well perceived by our users because they did no more feeling control. Suddenly, the bike is steering not necessarily in the same direction as the rider would do. So that's maybe either it's not a good idea at all, or our implementation was just bad and could also work on that. But at least my suggestion would be to rather go with things like adaptive cruise control. But of course, there are many other potential systems that we could try to translate somehow to these novel technologies. So why would we all do that? I mean, I showed you this picture of the city and the many, many cars that I don't think is very livable. So maybe we could give users something like these kind of things, smart, high-tech e-bikes that are as desirable as cars. So on Sundays, when I walk around the city, I sometimes see these young guys with their expensive BMWs at the parking lot at a supermarket. And I say, okay, if we want them to behave more sustainable, it will just not work to tell them, we'll take your cars away. But potentially we could create new products that would satisfy the same psychological needs, but would still help us to deal better with some of the global challenges.
So, Philip, with all this kind of modeling humans and AIs, playing with AIs in a way, we come back to this initial question about the relationship between technologies and human beings, right?
I mean, if I remember correctly, you call this an entanglement, right? So
I did.
I have no clue what this means, but I guess Chris can tell us something about it.
So entanglement probably is a term that you all know from physics. And in a way, it's sort of like connected to that a little bit. But this is a line of research that I've done over the last couple of years that tackles this question about the nature of our relationship to digital technology on a more fundamental level. And I'm using theories and concepts from the philosophy of technology and science and technology studies to get a real close handle on the way we think about technology and why that matters for creating technology and designing technology. I want to come back to this initial kind of argument about that we see the relationship is becoming somewhat different, and it kind of challenges very core concepts about what it is that we interact with. So you see the Pope again, coded bias, you see the robot on the other hand, but a lot of these things are implicated in very significant crises of humanity today: climate crisis, social injustice, political conflict, and actual wars. So the challenge now is to kind of think about who we might want to be and what these technologies make us. But beyond this initial argument, I want to maybe propose this as well. The way we conceptualize this relationship also matters tremendously because it determines what we can imagine to design. So the way we think about technology is actually scoping the space in which we can create and design space. And if we think about technology in different ways, then we might also be able to come to different solutions. And there are a few extremes. I want to illustrate this. We can think of technology as the most clever tool that serves human needs. But I think this is not quite our experience today. It's not just a neutral tool anymore, right? A lot of these highly autonomous systems, they act in the human sphere almost independently and autonomously in ways that we might not have under control. So there is something else than just a tool. Another way of thinking about this might be pressing human experience into numbers. This is more related to the way we see ourselves. So is human life kind of compressible in that way? Can we put a number onto every aspect of our human life or not? And can we represent that? And that shapes our life worlds if we think we do. And that also shapes the way we think about technology. Another extreme is evolutionary fusion. And that's, of course, this kind of thinking that technology is always just a natural extension to humans anyway. This is this very old idea of transhumanism that we at some point kind of merge with technologies and always have merged with technologies. You all wear clothing, for example, right? So in a way, this kind of makes us think about what is it then? What makes us humans? And this has been picked up, of course, in a lot of very popular science fiction movies like The Matrix or also 2001: A Space Odyssey. I want to illustrate why this matters for design by quoting Philip's book. And mind you, this book was written in 1994. at a time when AI was in principle kind of there, but has not reached this kind of broad audience because a lot of the compute power wasn't there, and also a lot of the data wasn't there. But he reflected on this kind of need about what is computation and what is human experiences. And I think he tries to kind of put something on the way we think about this as a generative metaphor. So how we think about this. And he calls the traditional way of how AI was invented a metaphor of mentalism. And he says, like, AI continually tries to assimilate the whole of human life to a small vocabulary. Human life, though, is far more complex and varied than any known means of describing it. As a result, technical discourses in cognitive science routinely employ their terminology in an extremely vague way to better assimilate the broad range of phenomena to a narrow range of themes. And he goes on to say that the usual idea of solving that problem is to make the ways of description ever more complex. So we expanding the vocabulary of how we describe human phenomena through data. And he says that's a systematic problem. And we already see the kind of big data AI maybe reaching its limits of, like, there is no other data that we can train our AIs on. So we're sort of like looking at this phenomena where we kind of thought like we can represent everything in the human condition through data and design and train artificial intelligence, and that's reaching its limits. And I think Philipp kind of has argued that this is a systematic problem. So in my work, I've looked at entanglement theories to kind of think about different ways of thinking about this relationship. And here you see some of the thinkers and philosophers that I draw. This is Wanda Olikovsky, Bruno Latour, Peter Pulverbeck, and Don Ide and Karen Barrett. And all of these have provided very different thinking, of course, but for the purposes of this talk, I tried to kind of focus on the commonalities of their writings. And I guess it could be summarized into 3 points. And one is that humans and non-humans, and particularly technology, are inseparably interwoven. And that's where the term entanglement is attached to. They're mutually constitutive. There is no humans without technology, and there's no technology without humans. And that's a quite profound kind of perspective, I think. And everything is relational. It's not that there are entities that this is AI and this is a human, but actually everything relates to each other. And it's where the relation is. That's where all the magic happens. And it's performative, and it's also highly political in that sense. And in tracing these relations, this is where we can create knowledge. This is where agency is distributed. And this is where things like responsibility can be found. So this might sound a little bit abstract now, and I want to illustrate this with an example that Bruno Latour uses in one of his books. And with this infamous kind of quote by the National Rifle Association, guns don't kill people, people kill people. So intuitively, you might say, this doesn't quite sound right. And the empirical evidence from the States obviously kind of tells a different story too. But the opposite is also not quite right, right? It's not that people don't kill people. They sort of do. They're implicated in any such thing. But what Bruno Latour points to here is that it's not guns or people that kill people, but it's the sort of relationship that you put a gun and a person in that creates a murderer and a victim. So if we configure these relationships in different ways, we might get different outcomes. We produce different ontological entities. Maybe not a murderer, maybe not a victim. In similar ways, Peter Pulverbeck thought about this as a mediation theory. You can think of like how we perceive and interact with the world is always mediated through technology. Think about your smartphone. You look into this smartphone and you're not looking at a smartphone, but you're actually seeing the world. And the way you perceive this world also comes back through this smartphone. But importantly, these technologies never mediate that perception and action in neutral ways. In fact, they're not just not neutral, but they shift our whole moral spectrum. And one of the examples that he and Olea Kudina kind of bring is prenatal ultrasonic diagnostics. Before we had that kind of technology, there was just an unborn baby. But with this kind of technology, we all of a sudden transformed the unborn baby into a patient that we need to make moral decisions on. So parents were put into situations where they actually have to make a moral decision about an unborn baby because of the knowledge that was enabled by a particular technology. So coming to the main point, what is it then what we do when we design technology, digital technology of today? We configure entangled networks of humans and technology. We create relations and sort of like hope for the best as they produce the reality that we live in. Sometimes that has worked quite well, and sometimes it has not worked that well. But as creators of technology, we are moral agents. We have a particular moral responsibility here. And we're also political agents. These decisions, think about it, there are very little things in our lives that have so profound impact on us, and that in terms of democracy are so far removed from our contributions. Nobody has voted for any of this, but we're customers. And we make us, right? It's the sort of like technology that we bring in makes us who we are. And this is the kind of thinking that I try to bring into my projects. And one of the projects I've talked about today is caring robots, but there are others like diversity computing spaces or social play technologies that are at various stages. It's always the attempt to kind of bring together people, technology, with a methodology of design and with a perspective of philosophy. And with that, I want to come to the last part of our talk today. And it's questions for future research. But before I do this, I want to make one last kind of argument, which is that in all our kind of examples that we brought today, I think it was quite obvious that this kind of non-trivial problems of humans and their computers is really non-trivial and can only be challenged if we look beyond the limits of single disciplines. So you can think about a discipline as a torch that looks at the world. And we've been really, really great in making the brightness of that torch better and better so that we see more of that world and can solve better the problems in that world. And for many problems, that's not a problem because the things that we don't see don't matter so much for these problems. But I would argue that for humans and computers and some of the challenges of humanity that they're implicated in, this is no longer the case. So what we really need is more torches. We need to look at the world from different sides. And the main challenge of interdisciplinary research is then to not only make the light of these torches brighter, but also have them talk to each other, to make the whole more than the sum of its parts. And this is precisely what ITU is all about, trying to kind of put this interdisciplinary center stage to kind of look at that world in more than one way and thereby get a very different handle on solutions that would address the challenges that we face today. So with that, a few questions that I still have. How can we really translate all these kind of quite theoretical concepts into design practice? What does entanglement HCI really mean in terms of putting it on the ground and designing computational artifacts? How can we create spaces for negotiation for meaningful technological futures? And what does AI mean for these kind of very fundamental human concepts such as creativity, agency, or consciousness?
Yes, thank you. And some more questions. First one was like, what are the potential dangers of highly realistic simulations of human beings and what are the potentials? As a mentor of mine once said after a lecture that was not very well attended, Philipp, one day virtual replicas of us will teach virtual replicas of students while we're all at home at Netflix and chill, watching movies of replicas of movie stars who died a long time ago. How can we create novel technology to solve global challenges rather than create new problems? And I think some of these problems we discussed today. And finally, of course, how can we agree on a shared reality when we live in distinct and highly adaptive planes of real and virtual environments? And with these questions, they should be the guiding questions of our discussion now. So we both thank you for your attention, and we absolutely look forward to have this discussion, also maybe answer a couple of your questions. Thank you.
So, Philipp and Christopher, so you both are from your background, you're really strong computer science, hardcore scientists. What made you want to work on such problems, want to go into interdisciplinary aspects?
So maybe my adventure into kind of philosophy of science, where I still feel a bit like an imposter, is really was driven by when I did some work with assistive technology. You said, like, I did visual or auditory displays for the visually impaired, and then worked with autistic children. And it made me aware that this is a hugely complex problem. And the more I needed to kind of understand of the problem, the more I became aware of how limited I was with my kind of strictly computer science goggles, right? I kind of looked at this and was like, oh, there's a problem, I can solve this. And then it's actually not solving the problem, because the problem is attached to all sorts of like various different things that I couldn't understand. And so I started to kind of look into social sciences, constructs of disability, normativity, how that is actually produced in our society, and then started to understand what disability actually meant. What is disability? And only then you can actually start thinking about assistive technologies, because then this becomes a different problem. And I think
this relation between problem framing and problem solving,
yeah,
so to understand better in a deeper way what the problem really is.
Yeah, absolutely. And I think we far less, we spent far less, too little time on problem shaping and too much time on problem solving. Understanding the problem is probably the bigger problem.
What about you, Philipp?
Yeah, I mean, for me, it was mainly curiosity. So I was already going to HTL Leon doing deep programming as a young boy, so to say. Then I started computer science. And at some point, I was just fed up of coding. And I thought, like, okay, what other fields could be interesting where I could just educate myself? And this HCI and user psychology appeared very interesting to me. And I also realized at that point, when I looked at what makes computing successful, that it were often these kind of developments at this interdisciplinary intersection. So you mentioned at the start the transition from a command line interface to a desktop interface that brought a computer from an expert system that a couple of nerds had into everybody's home. And I thought, okay, really successful computing applications should rather look at this intersection than mainly programming and other computer science topics.
So, but what was the real challenge then doing this? I mean, I assume it's not that easy to suddenly learn all about psychological aspects of attention and stuff like that.
I mean, of course, it's tricky because at some point you are a person that has no deep expertise in any field anymore, or at least this is how it feels to the real expert in these disciplines. So psychologists would say, yeah, I mean, that's nice, but that's baby psychology compared to what we real psychologists would do. Or I had the situation that when I presented work in computer science department, that people were saying, Philipp, what are you doing? Is that even computer science at all? So does it really fit here? These are the challenges that I experience, but I also think that these days people realize more and more that it's just no more appropriate to just look through these single torches anymore.
And I guess HCI has long been looked at as an interdisciplinary right? It's like a discipline that maybe sits and connects a lot of other disciplines, and that has been challenging for the field. And sometimes HCI also hasn't helped itself by kind of just going somewhere and taking methods out of anthropology and say like, oh, well, we'll do this as well a little bit and do that. And that became a problem, I think. But I guess there is real expertise and skill when done right, that you kind of go and take things from other disciplines and combine them in new ways. And see things in different light, right? I think that's some of the things that HCI really is very good at.
I guess so, but I also think that we as an HCI discipline have to learn in that space too, because often it feels like too easy to just I invent my method because I'm just not aware that there would exist a real method for the kind of question that I'm asking, but I'm not knowledgeable about it. So I think we as a discipline can also look to more into standardization of methods and increasing, let's say, the rigor of our scientific practices.
So I think for everybody who's in interdisciplinary sciences, that's my experience, there's this real personal story behind it, why you suddenly maybe go away from the purely technology to yeah, looking at the picture with different torches, as you were saying. How do you envision that we at ITU can teach or motivate our students to really see this picture and to motivate them to learn more about these different disciplines?
I guess it's always a little bit like with children. They need to kind of have a home base where they feel safe, right? And then going somewhere and seeing the world in a way that there's something beyond the limits of what you know, I think becomes really adventurous as soon as you know that you're allowed to do so. And you don't feel like an imposter every time you do that step. But it's acknowledged that, you know, that you go and read up on philosophy, and in the first years, you're probably only scratching the surface, right? And it's in these collaborations, I think it's really important to be very mindful that nobody knows everything, but there needs to be like a common language on how knowledge is created and how you can talk about problems. And I guess equipping our students with this kind of ability of looking beyond their own limits has something to do with self-confidence, building up their self-confidence, and also equipping them with some humility in a way that there's always something out there that is super interesting and can tell you more about the problem that you're currently working on.
Yeah, I think creating this melting pot of people, that's what can help us here. So not to say like, okay, I'm a computer science student, so I'm only involved in teaching in my computer science faculty, and I hardly see other people rather than at a Mensa Fest. So we need to create this melting pot of people with different interests and different backgrounds. And sometimes, yeah, I guess there are many people out there who may have made a degree in some arbitrary discipline maybe, but still are highly interested in technology. I mean, these days, many people have a high interest in technology. And combining the ideas of these people with other students who really have a strong background in computer science methods, I'm pretty sure we can create new things that we're not even aware of today.
Are there questions from the online community?
There are some, and choosing one, what are the potential risks of over-reliance on AI-driven behavior modeling in user interfaces?
Oh, wait. Okay. You said I should repeat this. I don't think I'm able to do this. Did everybody hear that? Okay, good. So,
Maybe that's a question for me. Yeah, there are high dangers there. Over-reliance is a big problem. We've seen in many applications where AI is used that, especially when a system works flawlessly for a longer period of time, people maybe pay no more attention to it, not the necessary attention that they needed. We've seen, for example, accidents with semi-automated driving systems like Tesla's, where it was even later on clearly attested that over-reliance was one significant cause for these accidents. What we can do about it, yeah, that's a good question. That's actually one of the big question marks in the kind of human factors research and automation research we're doing. And there exist many different concepts that range from providing explanations of AI behavior in real time to users, up to have them better educated about these technologies in the first place. I think there is a lot of more research to do to solve these questions. Engineers often then say in the end, so what if there is a clearly measurable benefit of these DI technologies? For example, regarding safety, when these kinds of cars lead to less dangerous accidents than if human would drive these cars, then already something was achieved. But personally, I don't think that's a sufficient answer. We have to care about the problem, of course.
And maybe also, if I understood the question right, it's like this over-reliance on human modeling for studies and user interfaces. One of the issues here is, of course, that we sort of like replicate the same, and there's the same kind of biases in the models will be replicated again in the user interface, because we model our user interfaces on these biases, right? And of course, there's no way of getting biases out of AI. Right? That's just per definition not possible, because an AI system is there to categorize and discriminate in a way that it kind of sorts out data, right? And builds categories. So I guess for us researchers there, I can see, these kinds of models being used in HCI, and they definitely have their place and value. But I think it's always important to kind of know when kind of real life differences might play a bigger role, and then go there and see whether any assumptions that have been produced are actually true or not.
Maybe let me add one more thing to that. Is like, when we build these kind of systems, we sometimes believe that putting them into reality will solve one problem, but then we'll realize over time that having these systems created new kinds of behavior that lead to additional problems that we have to resolve again then. So it's just a circle somehow, and
we see this a lot. Sorry, and we see this a lot with in highly complex systems like care, right? I mean, you solve one problem and you create a million different problems because you didn't look at the whole system.
True.
Are there any? Maybe we just open it here to the floor. Are there any questions to those two professors? Yes.
You've been talking about discrimination, mentioning, but isn't discrimination really human?
Yeah.
Within our human being, that we have a certain perception of interaction or
Absolutely. The difference, though, is that I know that you have a bias, and I know that you discriminate in positive and negative ways, right? But the numbers of technology and the way the people look at technology is a very objective one. And the problem there is that we see this again and again with recommender systems, for example, right? When they recommend things, we think that the machine has all the data. The machine makes an obviously objective choice, right? And that kind of picture of that kind of technology is wrong. And we're not very good in kind of relating to that in the right way. We're not very good with statistics or plausibilities or something like that, right? So in a way, I think the problem is not that something has a bias, but the problem is that the bias is hidden or not assumed.
educating people using technology is one of the key issues.
It's always said that education is stupid, right? That's what people say. Of course, we need to learn what these technologies are. But I think it's more fundamental than that. It's not just like learning the biases, but we also kind of, and that was probably what we kind of alluded to with this anthropomorphism of robots. We're sort of like having not quite the right assumptions about our technologies that we interact with, right? We assume that they're maybe a little bit like humans, or we assume that they're rational in their decision making and all of these things. What we haven't done yet is like kind of think about a concept that allows something like a machine personality, like where you think about a machine and it's like, oh yeah, a machine can be wrong. A machine is just a machine. I can kick it. It doesn't hurt, right? These kinds of things are, this is something that we need to learn collectively, but it's not like an educational task, but it's more like a fundamental ontological status of machines that we haven't got. And it is not helped that a lot of technological developments pay into these kind of human weaknesses in a way, right? They make it look cute to be more relatable. They make ChatGPT type an answer. There's no reason for this, other than the system trying to make us believe it's thinking. But it has the whole answer, and then it writes it out letter by letter, right? As if somebody was typing. And there's no technical reason for this, other than creating an image of a system that thinks, right? So in that way, we're manipulated into that. Exactly. So there's no reason of like, we need to be really careful about these manipulative designs, right?
Okay, so we're getting really deeply into philosophy. Are there maybe other questions out there?
Would be interesting.
Or more in that direction?
First, you know, Frauenberger, I think he's an important scientist because he's also from the region I'm from.
Of course.
And he built these vehicles, they call them Frauenberger vehicles, which are very simple, like the mechanisms, like they just follow the light or something. But then humans attached to them like very complex behavior. They thought, oh, this is like an animal or something.
Mm.
So I was just wondering, like, could you connect it? Because it seems also that we automatically put something into the machines, even if it's not here.
Anil Seth, he's a neuroscientist from the University of Sussex, has put that in a very nice way. I think he's speaking about some of these effects being impenetrable. So if the simulation is good enough, we humans cannot help but think there's something clever behind that, right? And that's the kind of danger of these kinds of designs in a way, because even though you could tell me this is a machine, and even though that you knew exactly that this RoboDog was a robot, you still couldn't help but have this emotion of feeling sorry. And there's an interesting point there. You know, what do we choose to design to make us believe these things? And should we? Right?
There was another question there?
There was one indeed. Moving from philosophical understanding to practical design execution. It wasn't me. What are some main traps to avoid?
In the design process.
Moving, yes.
Yeah, there are many traps. So I just want to build a bit upon the discussion that we had just ongoing. For example, if we should anthropomorphize robots or technology, and I would say it strongly depends. It strongly depends on where I want to use that particular technology, who is my user. Maybe it would make sense if it's a toy for children. For example, when we talk about these safety critical systems like cars, I always avoid that. For example, we have done studies in the past where we could show that just because in such a vehicle, the infotainment system was looking so nicely, so polished, so much like an iPhone, people believe that also the driving system on board must be high quality and it can never fail. So these are so-called halo effects where you would just translate one aspect of a technology that you can perceive to some other feature, and then it becomes dangerous, of course. So when it comes to design in general, in this HCI and user experience discussion, in the past, we had always the opinion that things should be as easy as possible for the user and the entry barrier should be as low as possible. And actually, technology has lost its innocence in my perspective, and we should rethink these concepts a little bit. So I think some of these AI systems, they can be addictive. They can be really dangerous. What do we do typically as a society when we have these kind of systems? For example, you would need a driving license to operate them. I'm not saying that you shouldn't have a license to be on the internet, but maybe we just need more time to really realize how we can categorize these kind of things, designs and systems in a way to make, to represent them better in society. So back then, for example, my grandfather often told me about story, how fun driving was back then when there was no license needed and there were no policemen out there and you could be as drunk as hell and drive around. And it was actually a very good decision that we're no more in this situation today. And I think at some point we will see similar things with technology as well.
Another trap that I could think of is like, for example, if nowadays we think a lot about ethical AI, it's been in everybody's kind of mind, and there's big programs on the European level, and of course that's kind of coming out of this realization that AI does something in society. And I think one of the traps of translating philosophy into design is here to oversimplify it in a way, because everybody who has read like moral philosophy knows that there are no simple answers to anything. And then trying to kind of make ethical AI a checklist that you go through and then your system is ethical will never be achievable, right? So there are complexities in philosophy that just need to be imported in their complexity and not kind of simplified into an engineering mindset. And I guess that is something that is really difficult, and I don't have a good answer on how we do this, because we really would want to have these concepts on the ground and not just at a university, but we want every technology company to think about how they develop their digital technology in good ways. And somehow we need to kind of come up with ways for them to do so without reading moral philosophy. Right?
This is where ITU wants to create those these experimental spaces where we can not only design, but also learn about design, designing human interaction, designing human ethics. And also we have an expert here now on ethics. This could be a further place on continue these discussions. And so therefore, there are more questions. Okay, then please, Mr. Also.
Question: how can we have the users keep their autonomy, and how can we get informed users? On the one hand, how can the design underscore and facilitate that users still keep their autonomy and are informed and know what they are doing and do not rely too much on the device? And this is a thing which partly depends on the design itself, but a lot of it depends on education, of course, from early age on to our students then. And I think this is a difficult decision always for the designers, and a plaidoyer of mine, not forget the users and give them the autonomy, and also let's train them or let's educate them or raise them themselves to think what are they doing with the devices.
Mm-hmm.
Just
Let me answer for that.
A very quick comment on that. Autonomy is a double-edged sword in that respect, because you don't want to be responsible for everything that a car does, right? So there are a few things that the car can do by itself, and I just trust that it works. And on the other hand, like, I want to still be maybe in the driver's seat, metaphorically speaking, and really. So I think it's a constant negotiation between autonomy and using your technologies and material world around you to kind of act in its own way, right? And there is the matter of trust, there is the matter of also the ethical kind of matter of, is it a good thing that happens or not? Am I being manipulated or exploited or in any other way? So I think this is something that is not going to have a simple answer. I think it's going to be negotiated all the time.
I think Mr. Perscher had also a question. Sorry.
Attention management.
I thought I would be able to hold this back, but I can't. Well, I'm somewhat trapped now in this entanglement story. It's inseparability of here is technology, here are humans. And this is mutually constitutive one to each other. And it is performative and relational, you say, and follow the associations. All this is not a surprise, I must say. We see that humans create technology. And ITU claims also to create technology in the future. It is also by the fact that humans create humans. And education systems like universities, they create humans from, say, the intellectual perspective. So ITU, having the mission of creating technology, maybe must also have the mission to create humans. Would you make a creative difference between creating technology and creating humans?
We can talk about authorship in this respect, but I guess you're sort of right in the way that we teach technology in this kind of very relational way. And you're right that these ideas are not new. Some of the texts that I was building on, they're like 20, 30 years old. And even Philagre's text on AI was from 94. Right? We have a short memory in technology, it seems, because we're rereading things. But in a way, of course, you know, the way we try and educate people differently at ITU also creates different people who then create different technology again. So I guess that speaks to this kind of entanglement of, you know, equipping students with different perspectives and torches that they then can go out and do different things, right? So yeah, that is a claim. We're not, I wouldn't go as far as saying we create humans, but we have the ambition to create students that are aware of, or that have that built in to think in different disciplines and create different technologies for that reason. So short answer is yes, I guess.
I want to add something for these last two questions that we had. So when it's about automating things, it's not always the question of let's automate everything what we can just because we can do it. But the question is also, why should we automate something and what would be then left for the humans using this automation? And the very engineering-centric perspective would be to go into a company and say, okay, it's no matter, I can automate that and I can automate that. And what you then do at your workplace, I don't care anymore. But this hopefully interdisciplinary mindset will create people who ask these kind of questions that automate only the things that still would leave meaningful activities back to the people who are at these places.
I mean, it speaks to this point, like what we think of technology also kind of makes us people, right? I mean, what does it mean to be human next to very intelligent and efficient machines is also a non-trivial problem, right? And I'm reminded of that tweet that went viral where somebody said, like, I don't want to have AI write my poem while I do the dishes, right? That's the wrong way around. Having an AI which does the dishes is ultimately a lot harder, right, than writing poems, it turns out. But I guess it's a connected question, right?
I think the poems, in my case, would be better if they're written by AI and I do the dishes. But
it's also about enjoyable things, right? Why would I want to automate something that I enjoy doing? It doesn't matter whether the poems are good or bad, but
one other thing, I asked my students, the students in the programming class, they were making pictures of the slide and say, hey, I use ChatGPT to solve this programming problem that you just gave us. I said, okay, Why are you doing that? Tell me, what is the fun of programming? Yeah, they said, you're thinking about a potential solution. I said, yeah, but what did you just automate? That fun part of the process, you will still debug that code. You will have to make it run on some machines, or you're just left with the ugly things that you don't like, actually.
This is a very nice end. Okay, so basically our synergy is like let's make sure people are not stuck with doing the dishes and debugging code. Thank you very much for your attention. I invite you for some drinks, some nibbles, and oh yes, we have our colleagues standing there at attention and available for giving you a tour through the ITU, specifically through our Learn Labs. So whoever is interested in this, please go in this direction and there you will find somebody to help you. Thank you again, and let's just mingle and network and talk a bit.